That's not what I want. Okay, so number 6 is the measurement question, I think. Okay, so I'm just going to write down which page I'm on. I'm on, I need a better color, page 275. Okay, we're going to start with number 6. So number 6, the length of a rectangle. So I'm dealing with a rectangle is 5 the length of a rectangle is 5 centimeters greater than twice the width. Ooh, nice. 5 centimeters greater than twice the width. So twice means 2 times. Okay, so watch this. 2 times the width plus 5. The length of the rectangle is 5. So the length is 5 times greater than twice the width. So Anna, I asked you not to speak just as I'm taking up the homework. Okay? If you really need to, step into the hall so you guys can talk. I don't mind. Okay? Are we good here? That was the trick. Okay? And then they're saying the area equals area is length times width, and the area is 33 centimeters. So we would go 2W plus 5 times W. So for the person, I don't remember who asked which question. For the person who asked about question 6, I think this is the hardest part. So do you want to ask me more? Like, is it cool? Yeah, great. Right. I think the setup is the hard part. So I'm not going to be solving these questions. If you need me to solve, then we can do that individually. Next was question 10. The area of a rectangular field. Okay, we've got another rectangle. The area equals 2275 meters squared. Okay. The field is enclosed by a 200 meter of fencing. What are the dimensions of the field? So what we're told is that there's 200 meters all the way around. So that's perimeter. Okay, this is a bit of a tricky question, but it's a great question. So perimeter is 200 meters. Okay, I also know that perimeter is going to be 2 times width plus 2 times length, right? That's how I find the perimeter. Okay. Now I'm like, I just need to have one variable. So I'm going to divide this entire equation by 2 to simplify it. So I get 100 equals W plus L. And that kind of makes sense. It's like, okay, so if I'm just counting the length and the width, that has to be 100 meters. And then the other length and width have to be 100 meters. So I could say, oh, look, length is going to be, what is length going to be? If I leave the length, bring the width to the other side, it's going to be 100 meters minus the width, right? If this and this side together are 100, then the length is going to be 100 minus whatever the width is. Okay, so in this case, I can say, oh, dimensions are going to be the width and 100 minus the width, right? That's my length. So when I say, oh, area is length times width, I'm like, okay, the area is 2275. The length is now represented by 100 minus W, and the width is still W. Ask questions, please. That is tricky. Why did you do that? How'd you get that? Person who asked for question 10, thumbs up. That helped. For anyone who was confused with question 10, did that help? Okay, let's move on to the next one. The next question you asked was question 12. So question 12 is a diagonal of a rectangle. Ooh, interesting. I wonder if we'll be using Pythagorean. I just wonder. Right? This is the diagonal of a rectangle. So when you have a rectangle, the diagonal is the line that goes through from one corner to the other. Now, if it's a rectangle, what does your math gut say? Are the two diagonals equal in length? Thumbs up, yes, they're equal in length. Thumbs down, no, they're not equal in length. Come on, everyone. Wake up, wake up, wake up. Are the orange and purple lines equal in length? They're both the same? They're not the same. Good, your math gut is correct. They are going to be the same. So it doesn't matter which diagonal I'm going to use. Okay, so what do we know here? The diagonal of a rectangle is 8 centimeters. The length of a rectangle is 1.6 centimeters more than the width. Okay, so we're all comparing it to the width. They're saying the length is going to be the width plus 1.6. Does that make sense? If it's 1.6 centimeters more, find the dimensions of the rectangle. Now, did they give you the area? They did not give you the area. So in this case, folks, I'm not doing the area problem. This is a hypotenuse problem, right? This is masked as an area because they give you a rectangle, but I don't know the area. So I'm actually just going to focus on this triangle, okay? So in this case, I'm doing an a squared plus b squared equals c squared. Okay, what is c squared going to be equal to? Okay, c, folks, is the hypotenuse. This is c. So if c is 8, c squared is 8 squared. What is my a and b? It doesn't matter, right? Fine, we'll make w my a, and that's my b. Okay, the a and the b doesn't matter which one's which because you're just adding up the square of the sides. And it's going to be equal to 64. Those of you who are confused by 12, is this helpful? Yes, no? Anyone? Wake up. Hi. Yeah. Okay. So if you want to, folks, like remember, this link is available to you. So if you want to continue working with this question, then please do so. Okay. And come up to me if you have questions. Lastly is 15, integers. Okay, listen to this. We didn't have this during class. The sum of the squares of 3 consecutive positive integers. I'm going to say it again. The sum of the square of 3 consecutive positive integers. What that means, I've got one integer and I find the square of it. I have another integer. I find the square of it. I have another integer. I find the square of it. And the sum of the squares is 194. That's the added trick. Now, they're saying consecutive positive integers. So, folks, consecutive positive integers. If 11 is my first consecutive positive integer, what's the next one? Is it 12 or 13, folks? Wake up, wake up. Yeah. No. Oh, yeah? No. That's the trick. You're so used to doing odd and even, folks, right? Consecutive positive integers. Did I say odd or even? I didn't. So what is it? After 11, what comes? You got it. And then 13. So it's really reading it carefully. I didn't say odd, or the question doesn't say odd or even. So if this is an example, how do I get from one integer to the other? What do I add? Plus 1. And then for me to go to the next one, what do I have to add? Plus 2. So I'm going to have x as my first integer, x plus 1 as my second integer, and x plus 2 as my third integer. Put your hand up if that makes sense. Yeah, Catherine, does that? I feel like that. Yeah, I realize. Good. Okay, so we're really checking. Are they saying odd, even? Now, this question is saying positive integers. And do you know why that's important? You're going to do the quadratic formula or you're going to factor and you're going to get, oh, x equals, I don't know, I'm just going to make something up. 3 and x equals -5, for example. Which one am I going to cross out immediately? Yeah, that's right. Because what word do you see in the question? Positive. That's right. That's what the positive is saying. It's like, yeah, you're going to get a -1, but I just want to know the positive ones. Okay? Questions about this? All right. So folks, this is posted. I'm going to stop the video. I'm going to post